What up? Tyler here from TarverCounty.com. We're talking about real numbers, multiplying them, dividing them, etc. First thing I want to talk about is the identity property of multiplication. Okay, that's essentially, you're talking about multiplying, and you're talking about its core identity, like its core pillar of what it is, and that's multiplying times 1. Okay, it sounds cheesy. It's very basic. It's something you learned like in kindergarten or first grade, but it's something that needs to be reinforced and now has a name. You didn't get that name in kindergarten, okay, but now you got it. So what that means is for any real number, n's a real number, and again, real numbers are pretty much any number you'll use in math until you get to like Algebra 2. Maybe touch on it in this subject. 1 times n equals n. That means 1 times any number is going to equal itself. Okay, so like 1 times 4, it's going to equal 4 every time. 1 times -5. Oh, well, that's different because that's a negative. Yeah, no, it's not different. It's still going to be -5. Anything times 1 is going to be itself. A billion times 1 is a billion. Billion. What up? All right, so what we're going to talk about is the multiplication property of 0. And you're thinking to yourself, Tyler, Mr. Tarver, depends on how formal you want to be. Anytime, everybody knows, anytime you multiplication times 0, it's always going to equal 0. Well, 1, I don't know why you're talking like some Georgia person from like the 1800s. That's fine, whatever. Multiplication property of 0, I would tell you are absolutely correct. Okay? Anything times 0 is 0. So say you got 41 times 0. The multiplication property of 0 means that anytime you multiply times 0, that number is going to be 0. Okay? You're thinking that's easy, I don't need to learn that, I know that. You do. But what you now have learned is what it is actually called. The multiplication property of 0. Alright? And it's easy to remember. It sounds complicated because it's got a lot of TIONs and TYs and it makes it sound fancy. Just remember, anytime you multiply times 0, it's going to be 0. No matter if 0 is on the front, times 41, it's still going to be 0. If it's a negative, -2 times 0, oh yeah, that's going to be 0. -4 billion and 8 times 0, that's going to be 0. The title of that is the multiplying property, it's a property of, it's a word, 0, it's a number, okay? That's a core pillar of math. I want to talk to you about the multiplication property of -1. All right, it is exactly what it sounds like. Multiplication means you're multiplying by -1. That's it. So this is something most of you know how to do, but it's also a core property in multiplication, one of the 3 core properties. I've got videos on the other 2. I don't want to spoil the surprise, okay? But what it means is whenever you multiply times -1, so if you got 3 times -1, that's our money one right there. That's what we're talking about. It's always going to be the inverse of that. It's going to be that same number with the opposite sign. Okay? That's it. That's the multiplication property of -1. It means all you're going to do, anytime you multiply something times -1, all you're doing is flipping the sign. That's it. Okay? It's whatever that is, but as either the opposite of the positive negative. Easy way to do it is you're either turning a negative to a positive or positive to a negative. Just switching it, okay? So let's look at it here. We've got a positive 3 times -1. What's the opposite of the positive? It's a negative. You're just flipping it. So say you got -1 times -2. -1, 1 times 2 is 2, so we know that's always 2. But what it does is it flips the sign. So now instead of this being a positive or a negative, it's going to be a positive 2. So we've got -3 times -1. Still going to be 3, and that is going to flip the sign. That becomes a positive. Say -1 times 8. That's a positive 8. Now it becomes a -8. And that's the multiplication property of -1. You just flip the sign. Take the same number, flip the sign. That's it. What up? Tyler here. I want to talk to you about multiplying 2 positives. Whenever you multiply 2 numbers that are both positive, you have no reason to be in the negatives. It's like your mom when she's like, oh, honey, you need to hang out with Billy. I was going to say Jilly. That's not a word. That's like a girl's name with a Y on the end. Honey, you need to hang out with Billy. He's a good boy, and you're a good boy. Y'all be both good boys. It's like not bringing any of like your crazy friends in. They're like, hey, let's jump off this roof. Don't jump off roofs, okay? That's Jake the snake. He's crazy, okay? So that's like the negative. If you have two positives, only good's going to come out of it. So when you're multiplying like 3 times 4, there's no reason that'll be a negative. It's going to remain a positive. It's going to be bigger. 3 times 4 is 12. Anytime you multiply two positive numbers, 1 times 5, it's a positive 5. 16 times 4, it's going to be 64. It's always going to be a positive. Anytime you multiply two positives, it's going to be a positive all the time. What up? Tyler here. All right, I want to talk to you about multiplying two negatives, okay? So what happens when you multiply two negatives? It's the same thing as if you're subtracting a negative. If you've ever seen my video on that, when you multiply two negatives, it turns into a positive. So if you've got negative 3 times negative 4, it's going to be a positive version of whatever those two are multiplied anyway. So 3 times 4, just 3 times 4, without any signs, is 12, right? Whenever you multiply two negatives, it's always going to be a positive number. So that stays positive 12. So you've got negative 12 times negative 4. Well, that's different because the numbers are bigger. No, it's not different. It's the same thing. Two negatives is going to be a positive. What's 4 times 12? 48. All right, so let's do 3. I don't know why I keep using the same numbers. 3 times 7. And let's make them both negatives because that's what I'm talking about. Negatives are always going to multiply to a positive. So 3 times 7 is 21. It's a positive 21. Two wrongs make a right, but only in math. Not in real life. Do not go do anything crazy. Because two wrongs only make a right in math. Tyler here, TarverAcademy.com. I want to talk to you about multiplying numbers that have different signs. Okay? What I mean by that is you're multiplying a positive and a negative, or you're multiplying a negative and a positive. I just mean that you got two numbers, that's 4, two numbers, one's a positive, one's a negative, doesn't matter the order, and you're multiplying them. Spoiler alert, it's always going to be a negative, all right? You've ever heard like your parents talk, your teachers talk, and they're like, you shouldn't hang around bad people because they're going to bring you down a lot easier than you can bring them up, all right? Whether that's true or not, I'm telling you, it's the same concept, okay? The negatives always overpower the positives. So when you multiply two numbers and one's a positive, one's a negative, or one's a negative, one's a positive, anytime you multiply two numbers that are opposite signs, multiplying them, it's always going to be a negative. So the easy way to work these, I'm going to give you a shortcut. The easy way to work these, just multiply the two numbers. Forget the signs. Multiply the two numbers. 2 times 3 is 6. I know that. Everybody knows that. You know that. If one of them's a positive and one's a negative, I just told you that number is going to be a negative always if you're multiplying two different signs. So I can just stick the negative there. I can just multiply. 4 times 7 is 28. One's a positive, one's a negative. I know this is going to be negative 28. 8 times 2, 16. I know that one's a negative, one's a positive. It's going to be a negative 16. Anytime you multiply two numbers, and I've said it a bunch, but I'll say it again. Anytime you multiply two numbers, and one is a positive and one is a negative, the answer is going to be a negative of whatever those two multiplied together is. Can't be any more. What up, everybody? Tyler with TarverAcademy.com. I want to talk to you about evaluating expressions with multiplication, okay? So, again, evaluating expressions means that you're given what some things equal, one thing equals, or multiple things equal, and then you're going to plug them in to an equation and either try to solve it or simplifying it. So you're evaluating those expressions to figure out a better result or a more conclusive result. All right, that was a complicated way of saying just plug the stuff in for what it equals. So we've got 3 different problems here. First one, we've got 4AB. Now the two things I was given are that A equals negative 3 and that B equals 2. I'm going to separate them two right there. I don't want to get them mixed up. So A equals negative 3, B equals 2. So anywhere in these problems that I see A, I know that I can replace it with -3, and it's the exact same thing. The thing you got to be careful of is that you put it in exactly for A. All right, so let's look at it. 4 times A times B. So I know 4 is still going to be its own number, times A, which I can replace with -3. The easiest way to not get mixed up when you're messing with all these signs and stuff is to put them in a parentheses and then start simplifying. And then I'm multiplying times B, which is the same as +2. Now I can just use my order of operations to multiply it. 4 times -3 is -12. And I still got to do -12 times 2, which is -24. All right, next we've got negative, parentheses, A times B, close parentheses. This is where it gets kind of crazy and people mess up. Okay, so just stay with me. I'll walk you through it so that you don't mess up. All right, so we've got negative AB. Keep everything the same until you do what I said with the parentheses. So we got negative, parentheses. A is -3. A lot of people will be like, oh, it's already got the negative in the parentheses, I'll just put a 3 in there. Do not do that. Wherever A is, exactly where A is, replace that with -3. Okay? You can put it in parentheses again if you want to. Whatever, I don't care, as long as you don't mess up. And then B, I'm going to replace with 2. Now if I got too many parentheses, so I'm going to close that. Now, before I get to that negative, I'm going to do what's in there first. So -3 times 2 is -6. So I'm going to keep all my signs still there. A negative times a negative equals a positive. Okay? So it's +6. Okay? Cool. If you want to put that in your calculator, make sure you put all the parentheses you need to put. So you need to put negative, parentheses, parentheses, -3, minus, it doesn't matter. Minus sign, parentheses. I guess, in your calculator will do it. Yeah, you can with subtraction. Minus blah, 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 and you'll get that, okay? So make sure you get all those parentheses, because if you don't, it's going to mix up those signs, okay? Next, we got negative B, parentheses A, okay? B is a +2. You're like, oh, I don't need that negative, it's a positive. Put it exactly where it is. Bring down the sign, then put that in parentheses. B is 2. And then already in parentheses is -3. The negative times 2, that's the same as -1 times that 2. It's not minusing 2, it becomes a negative. So it's -2 times -3, and that's -6. You got your answer. Now you've been evaluating expressions with multiplication. It's fun, right? What up? Tyler here, Tarver Academy. I want to talk to you about simplifying exponential expressions, okay? So, what we're going to do here is we're going to simplify, which means make it like you're not solving it, but you're like making it like as simplest version possible, like breaking it down until you get to as most compact as you can. And exponential means it's got exponents, and expression just means it's like a math thing, okay? So let's start with like -4 squared, okay? So if I wanted to simplify this, it would be essentially like breaking it down and then multiplying. The part that makes it crazy is that 2 is outside of a negative. So usually if it's like 4 squared, you're, oh, it's 16, 4 times 4. This one's a little different because you're actually, since it's outside the parentheses, it's attached to everything inside of the parentheses, which includes that negative. So that's the same as saying -4 times -4, which is still going to be a +16. Now let's look at one that wouldn't be quite as simple. So let's say we got -2 cubed. That's -2 times -2 times -2. All right, this one's a little different. Here, a negative times a negative equals a positive. Here you're doing a negative times a negative does equal a positive. It's +4. Then bringing it down, that's times -2, which equals a -8. Okay? I'm going to show you a trend here. If you're if you have an exponent and it's including a negative, it includes the negative in there. If that exponent is positive, it's positive. It's throwing positive. Most of them positive. If that exponent is an even number, it will be a positive. If that exponent is an odd number, it's going to be a negative because it's like flipping back and forth. Like every other multiply, it's going to go from positive to negative to positive to negative. So if it's an even number, it's going to be a positive. If it's an odd number, it's going to be a negative. Okay, let's look at a couple examples that will probably trip you up. Okay, so let's say we got -4 to the 4th. Say -2 to the 6th. And then let's say negative 3 to the third. All right? Here we go. All right, so I've got, let's do this. Let's add a number in there. All right, so let's start with the first one. This is where you're gonna mess up if you're typing this in a calculator, okay? When you type this in a calculator, any of these problems, if you see parentheses, type the parentheses in. A lot of people will get lazy and just type it without the parentheses. It's gonna give you the wrong answer. And this is why. The differences between these two problems right here. Whenever you type this in, that 4 exponent is not attached to both of these. It's not attached to the negative. Even though the negative has no other owner besides the 4, it is not attached to that exponent. That exponent is very clingy. It's like one of those birds that sits on a rhino. It's only attached to what is directly hitting. Now, with parentheses there, it means everything inside the parentheses. Like that 3 is not attached to that 2 because it's there. This one, that's there. Here, it's literally only touching that 4. It does not approach the negative, okay? So let's see, 4 to the 4th, that's 4 times 4, which is 16, times 4, which is 64, times 4, which is 252, I think. Hope I got that right, okay? I promise I didn't do that beforehand. It's been a while since I've done that math. 252, and that negative just comes down. It's like the negative just like steps back and goes, all right, do your math, do your math. Hey, do your math, hey. That's Juju on that beat. All right, so it goes in, and then you just do the number and stick the negative back in the front, okay? Let's look at another one. This one's different because the negative is in the parentheses with it. So therefore, whenever you're doing this exponent, multiplying something times itself, times itself, times itself, the negative is going to join the ride, okay? So we've got negative 2. All right, first off, is this going to be a positive or a negative whenever I get done with it? I told you earlier, it's going to be a positive because that 6 is an even number, which means it's always going to end up being a positive number. So I could really drop the negative and make it 2 to the 6th and find my answer. We're not going to do that because I kind of want to illustrate it to you. So I'm going to bring it down here so I have room. Negative 2 times negative 2. I got to make 6 of these. There's 3, 4, 5, 6. Man. All right, so let's do the first two. That's negative 2 times negative 2 is positive 4. Now I'm multiplying that times negative. Sorry, I did that weird. That's 4 times negative 2 is negative 8. And I'm going to go up here. Negative 8 times negative 2 is negative 16. And then I'm going to go up here. Negative 16 times negative 2 is positive 32. I think I did something wrong. 1, 2, 3, 4, 5, 6. And then 16 times negative 2 is negative 64. That doesn't seem right. Is that right? That's not right. Where'd I mess up, guys? Where'd I mess up? Help me. I'm going to keep this real. I'm going to keep it real. You know, Tyler, going to keep it real. Negative 2 times negative 2 is a positive 4. Times negative 2 is negative 8. Oh, I messed up right here, guys. Negative 8 times negative 2 is positive 16. Did you catch that? If not, just keep watching. Don't zone out. Don't stare at your phone. Get off your phone. You ain't really texting your mom. You're on Snapchat. 16 times negative 2 is negative 32. Negative 32 times negative 2 is positive 64. I would not have caught that if I didn't look at this beforehand and know that I was going to get a positive. I would have just been like flowing and working and being done. I'm going to stay real though. All right? 2 times negative 3 to the third, or cubed. All right? Again, it does not count that 2. It will count the negative because it's in there. You know, since that's an odd number, you're going to end up with a negative number because it's going to flip back and forth, and it's going to stay a negative. So negative 3 times negative 3 is positive 9 times another negative 3, which is negative 27. So 2 times negative 27 equals another negative, because you know positive times a negative is a negative, is 54. That's your answer. You just learned it. You just learned it. That's what's up. That's what's up. Thank you for joining me. Peace. Dividing two negatives. So we're going to divide negative 6 divided by negative 3. All right? The ultimate rule and the shortcut and cheat code of dividing two negatives is to know that it's the exact same positive negative rules as when you multiply two negatives. When you multiply two negatives, negative times a negative equals a positive. Same thing here. A negative divided by a negative equals a positive because the two negatives kind of cancel each other out. So negative 6 divided by negative 3 it's going to cancel out, so I can just look at it as 6 divided by 3, which is 2. And I know it's going to be a positive 2. And another way to backtrack that or back channel that, if you wanted to do the opposite of divide, which is multiply, 2 times negative 3 is negative 6. And that's kind of the reasoning here. Justification, that's not a word. Not justification, but justification. That's not right. That's a legal term. All right, same here. So negative 12 divided by negative 4. It's another way you'll see division signs. A good way to think of it is, like, it's like the two cancel each other out. So those cancel each other out, and then it's just 12 divided by 4, which is 3. Okay? So anytime you divide two negatives, it's going to be a positive. So if you've seen my other videos, you know that when you divide two negatives, it equals a positive. Always. Anytime you divide two negatives, they're going to cancel out, make it a positive. So when you divide two positives, you think, oh, well, this is going to be a negative, obviously. No! No! We never want to bring negatives into the situation at all unless we have to, okay? And they are not being brought in with two positives. So say you've got 8 divided by 2. If those are two positives and you divide them, they will always be a positive. So 2 goes in 8 4 times, boom, you're done. A way to backtrack that, opposite of divide is multiply. 4 times 2 is 8. So we know they did that right. So let's say we've got, let's do 18 divided by 9. Two positives, when you divide them, it's going to stay a positive. You know that. You know it. Forget about it. 18 divided by 9 is 2. And you done. And you done. So now we want to talk about dividing a negative and a positive, or vice versa, dividing a positive and a negative. Anytime you're dividing two numbers and they have different signs, what does my answer look like? Or another term for the result of division is a quotient. What does my quotient look like? It's going to be a negative every time. If you've got one that's a positive and one that's a negative, the negative's always going to stick around. It's like, don't they say something about, like, if you drink poison, it's always kind of with you or something, or if you get like the flu, I don't know the term, but it's always going to be there. So let's say you've got 8 divided by negative 2. Anytime one of the numbers is a negative, that would be this one, and one of them is a positive, that would be this one, the answer, or the quotient, is going to be a negative. So 8 divided by 2 is 4. I know it's always going to be a negative. Boom. Way to backtrack to see if you got it right. The opposite of divide is multiply. Negative 4 times negative 2 is positive 8. So we know we did that right. Let's say we've got negative 16 over positive 4. Okay, now it's this kind of division sign. Well, same thing. Our answer is going to be a negative because when you divide, and one's a positive, one's a negative, always going to be a negative. Negative 16 divided by 4. 16 divided by 4 is 4. Okay, so it's almost like the sign does its own equation, and then the regular number does its own equation. And then they hang out and drink Starbucks coffee because it's delicious. Inverse property of multiplication. It's almost like division doesn't exist. It's like the opposite of multiplication. Like multiplication is like the king, and then division is like the man in the iron mask, okay? That's a reference no one will get. It's a good book. Inverse property of multiplication. I think it's a book. I know it's a movie. I'm not that classy. I didn't read the book. I don't think I did. Maybe I did. Let's say I did. You don't know. I'm not going to edit this, so no, I didn't. I watched the movie. Inverse property of multiplication. It means that whenever you multiply something, there are two opposites of each other. Okay, that's not the right way to say it, but it's the simple way to say it. All right, so it's like A times 1 over A is going to equal 1. All right, so what that means is, like, say you've got 5. We want to find the multiplicative inverse. Multiplicative, see in there, inverse. We want to find the multiplicative inverse of that 5. Because essentially we want to know, what do I multiply that by to equal 1? That's what the multiplicative inverse. So remember the multiplication property, identity property, or whatever it's called? Identity property of multiplication? It's where you multiply something times 1 and it's going to equal itself. This is like the flip of that, the inverse of that. Hey. Okay, so what times that equals 1? Well, it's always its own number underneath 1. All right, why, you ask? When you multiply fractions, like people see fractions, they just freak out. It's not that bad, okay? You just got to know a couple of rules, feel comfortable, and then it becomes natural. When you multiply them, you know this is always over 1. If you've got a number, it's always over 1, then you just multiply across. So 5 times 1 is 5. And then we know it's always over 1, so 1 times 5 is 5. 5 divided by itself, how many times does 5 go into 5? 1 time. Okay? So that's the official way. The simple way of remembering it. What's the multiplicative inverse of 1 over 7? Guess what? 7, because when you multiply them, they equal 1. The multiplicative inverse is always whatever that number can be multiplied by to equal 1. That's what's up. What up? So we're going to talk, man, stretch. So we're going to talk about multiplicative inverse, aka the reciprocal. You'll hear it more commonly referred to as reciprocal. It's like its street name. The reason is multiplicative inverse is hard to say. Say it 3 times fast. Multiplicative inverse, multiplicative inverse, multiplicative inverse. I did it because I trained for years. That's the only reason I can do it. It's like the Princess Bride. Drink a little bit of the poison every day to become immune. Don't do that. That's very bad for you. I don't think that movie is true. It's not a true story, I don't think. I'm not sure. Okay, so we want to talk about multiplicative inverse in solving problems. So here's an example. Solve x divided by y when x equals 2 over 3 and y equals negative 4 over 7. Okay? So the first thing I want to do is I want to rewrite this. I know x divided by y is the same as saying x divided by y. Whenever you do fractions, you don't want to do it like stacking, fraction stacked over a fraction divided by, that's too much, okay? Nobody wants that. It's a leaning tower of, oh no, I'm going to mess up and fail my class. So x divided by y equals, now I'm just going to plug in my x, which is 2/3, divided by y, which is negative 4 over 7. Now, when you're doing this, you're like, oh, the negative's there, I'm going to subtract them. Oh, if that negative's there, I'm just going to start subtracting. Don't, okay? Just give the negative to one of the numbers and let them keep it, okay? It's like 4, you hold on to the negative. Or I can give it to the 7, doesn't matter, just give it to one of them, not both of them, and not neither of them. I'm going to give it to the 4, he's going to hang out with the negative, okay? So what we're going to do is, you're like, I know how to multiply fractions because it's pretty easy. You just multiply across the top, multiply across the bottom, and you just put them where they go. With dividing fractions, you're going to do the same thing, except for there's like one step, and you got to flip. You got to find the reciprocal, which means you got to flip it, okay? So for instance, I've got 2/3 divided by negative 4 over 7. I can turn that into 2/3 times that, but I have to use the reciprocal. I have to use the multiplicative inverse. So I'm going to rewrite it, 2 over 3. I'm going to make it multiply. I have to flip it. So there has to be like a sacrifice for switching division to multiplication. You can't just do it. It changes the problem. But you can change it to multiplication if you flip it. Okay? So now negative 4 goes from the top to the bottom, and the 7 goes to the top. Now we can just multiply across the top. 2 times 7 is 14. 3 times negative 4, negative 12. Can I simplify that? Absolutely. They're both even. I know 2 goes into both of them. How many times 2 go into 14? 7 times. How many times does 2 go into negative 12? Negative 6 times. We have our answer, ladies and gentlemen. And that's what learning looks like. Oh, hey, it's me, Michael Jordan, Shoemaker. I want you to know that if you don't click that little circle there to subscribe, then you won't ever find your true love. That's a fact. It's like an email chain letter. If you're not 45 years old, you will not get that joke. Not important. But click that. Anyways, I'll wait.